Alright, this is going to be the review sheet number 2 quick video. So you don't have to watch this entire thing unless you want to. If you need help on one of these questions down here, you can just kind of skip ahead to the video and use whatever you need, but I'm going to give you some hints. Okay, first of all, listing out the first 15 prime numbers. You should be able to do this. I mean, hopefully we're getting to the point where we understand what prime numbers are. Remember, a prime number only has two factors, one in itself. So, I'm not going to give any away, but they can only be divided by one, or they can be divided by themselves. So, what I would do is I'd be looking at my chapter 1 notes, because if you guys will remember, and I believe the learning target number 4 and number 5 video, I actually give you those first 15, and you can look right in your notes, and you're going to have them. Explaining why 1 is not a prime number, that's right in your notes, right in your video as well for that learning target 4 and 5. So you can go there and reference that if you need to. Just remember, a prime number, I gave you this up here, only has two factors. A composite number has 3 or more factors. Okay, so use those two things to try to figure out why 1 is not prime and it is not composite. It would be considered neither. Okay, rounding, just a quick little review. This first one to the left, to the right of your decimal would be your tenths. The next one to the right would be the hundredths. Hundred, you write the word hundred with THS on the end. Next one will be thousands. So regular word thousands with THS on the end. Going to the left, you would have the ones, the tens, the hundreds, and then the thousands. No THS on the end. Okay, so remember, when you're rounding, okay, since this says to the nearest number, so I'm going to make up another one. So 728,562, something like that. If I'm rounding this to the 100, I'm just going to do this example. You have to do this one, but I'm just going to give you the example. I have to figure out where the hundreds is. So first thing I got to realize is that is a whole number. So I know the decimal must be after the last number. So if I know the hundreds is the third one to the left of the decimal, I'm going to go 1, 2, 3, and I'm going to underline that 5. And I'm going to draw my arrow to the number to the right of it. The number to the right is going to tell me what that 5 is going to do. Everything to the left is going to stay the exact same. Nothing changes with that. The only thing that's going to change is the numbers where I'm rounding and to the right of where I'm rounding. So when I look at that 5, I look over to the 6 for a little bit of help. Now remember the rules. I'll write this week, but I'm not going to write it after this. 5 or more, and then you raise the score, or the number goes up. Okay? 4 or less, you're going to let it rest, or the number's going to stay same. You guys all wrote this on your review sheet today. Review sheet number 1. So you should have written 5 or more, raise the score. 4 or less, let it rest. Okay? Let me go back now. So I have to figure out if that 6 right there is 5 or more, and it is. Since it's 5 or more, that tells me that this has to go up. So this 5 right here, try to do this in different colors, this 5 I know has to go up to a 6, because that 6 is 5 or more, which tells that to go up to 6. And then I know that wherever I'm rounding, everything to the right of where I'm rounding is going to turn into zeros. So I know that's going to be a 0 and that's going to be a 0. So that's how you would do a rounding question. Okay? So you need to apply that to all of these. Now, I'm just going to tell you right now, this one here, I'm just going to go ahead and give you the answer. It's a little bit confusing. Okay, it says round it to the nearest whole. Well, this thing is already to the nearest whole number. So basically it doesn't change. It's kind of silly. I don't know why we forgot to change that or make that correction from last year, but it's just the answer. Now, if there was a decimal on there, like 0.5, then you would round to there and make that either a 6 or stay at 5. But since there is no decimal, your answer is that. So I just gave you the answer to that one. Everybody should get a big giant check mark right there. Okay? Exponent number 3. Okay, now I'm going to give you a good example here. Now, I'm going to show you how to, I want all these turned to decimals, so that's going to be your instructions here. I'm going to say, it says you can use common denominators. I'm fine with that method if you understand it, but I think the decimal method is going to be a little easier for us right now. So I'm going to say turn to decimals. Okay. So I'm going to do a quick example here. I'm going to do, let's do 2/3 and 5/6. If I was asked to figure out if it's going to be a less than or a greater than symbol in between there. You know what? I'm just going to go ahead and show you both ways, common denominators. So if I were going to find a common denominator between 3 and 6, I'm going to, and we're going to learn about this chapter, but there's a couple different ways. The first way is to just figure out what if they share a multiple. So 3 and 6, they share the multiple 6. So it's easiest just to change that to 6. So that would be times 2. And then whatever you do to the bottom, you must do to the top. That's going to be 4. And then we have 4/6 of pizza, and we have 5/6 of pizza. Clearly, that's going to be the larger one. Okay. Now, that's the fraction method, and I'm cool with you doing that way. I'm totally okay with it. So if you want to do that on number 1, you just got, it's a mixed number, but you still got to find a common. Do whatever you did to the bottom to the top. If you the other way, the turn to decimals method. So here we go. And how you're going to do that is you have to understand, and you're going to hear me say this a lot, all fractions are division problems. You're going to hear me say this all year long. All fractions are division problems. Learn it, get it prepared, because I'm probably going to be in class and I'm going to be like, okay, I'm going to start this sentence and I want you guys to finish it, and I'm going to say all fractions are what? And hopefully all of you say division problems. So what that means is, in order to turn this into a decimal, you're going to do 2 divided by 3 and 5 divided by 6. Okay? When you do this, this is going to give you 0.6 repeating, which is a little line over it. Okay, and that's going to basically say that it goes on forever and ever and ever. Whoops, sorry. And then when I do 5 divided by 6, hang on. Okay, and you can use a calculator for this division. I don't expect you to do it in your long form. That's, I mean, we're practicing a different skill. 5 divided by 6 is going to give me 0.83 repeating. So it's 0.8, and then the line goes over the 3. Okay? Now, just like we did on review sheet number 1, we're going to take those and we're going to stack them up. So I know that this is going to be 0.83, and we don't want to list out all those 3's. We're going to just go to here. That's all we're going to go to, because we can learn enough about it. And then I'm going to do 0.6, and I'm going to put another 6, because again, that's 6 repeating. Okay? And then remember, when we're comparing decimals, we work our way from the left to the right. Okay, so we start here in the tenths. If we find one of them that's bigger, it makes that whole number bigger. So because 8 is bigger, it doesn't matter about this. We know that this must be the bigger number, just like we proved up here. 5/6 is bigger. We just proved again that 0.83 is bigger than 0.6 repeating. So we know that that answer would be the same no matter how you do it. Okay? So you can do that either one of those methods. The one thing I will say is when you do this one, when you turn that to a decimal, you got to understand that 3 and 2/7, that's going to be 3 point something. Okay, that's saying a whole number 3, so that just bumps down. So to turn 2/7, we're going to do 2 divided by 7 to turn this to a decimal. Again, you can use a calculator. And then there we go. Now I know it goes on and on forever. My advice, just go to 3 places. So I'm going to round right there to that 5. So since 7 is 5 or more, it's going to be 0.286. So 3.286. That's how you make that one into a decimal. Okay? These other ones are already decimals. This one down here, you'll have to show your decimal work on those, or the fraction work, but just turn it to decimals. Okay? So I would have to see work on this question. If you have no work, you will not get credit for this box. Remember, the whole box is worth 1 point. Okay? Range. If you need any help with range, first of all, you could look it up on the internet. But if you look back to review sheet number 1, I put the definition of range on there. You should have written it because I wrote it. I asked you to write it. So you can look back to your review sheet number 1, or the video that's posted in the review sheet folder. You will see how I explained range. Median, let me make up some numbers here, 20, 21, 19, 18, 17, something like that. What median is, median, the first step to doing median, well, first of all, the median is the middle number. It's the middle number. So I know that when I look at this, the first thing I've got to do is I've got to put these least to greatest. So I'm going to do 17, 18, 19, 20, and 21. Okay? And then what we're going to do is we're going to cross off the smallest and the biggest. Smallest and the biggest. Until I get to the one that's left in the middle, I know that my median here would be 19. Okay? So now you need to apply what I just showed you to this up here. So yes, you have to show work on this one. It says show how you found the median. That would be the work I need to see. Okay. Prime factorization. This is learning target number 5 of chapter 1. So look back in your notes on that to try to figure out what the correct prime factorization is. Look back at practice. I'll do a quick one over here. I'll do 36. I'm not going to do the one that's there for you, and that would just kind of give you the answer. So if I were doing 36, I would want to break that into 2 factors that would multiply together to give me 36. So there's a couple different ways you could go about this. You could do 4 and 9. You could do 6 and 6. There's a lot of different ways you could do it. So I'll just do 4 and 9. 4 would break down even farther to 2 and 2, which those 2 are prime numbers. They're only divisible by 2 in its, or 1 in itself. 9 would break down to 3 and 3. The correct answer for this one would be 2 times 2 times 3 times 3. That is the prime factorization for 36. Now you're going to have to go in and do your own prime factorization for 24. So yes, I would have to see the tree. I would have to see this work right there. Okay? Let's go on to the next one. Here, I'm not going to do any examples. You have to show your work. If you don't actually line them up and show this, you will not get credit for it. So if there's any borrowing that needs to take place, you have to show it. If you don't, it's wrong. If you need any extra space, they're all the way on the back of this, there's extra space. This is from the learning target number 1 through 3 part of your notes, chapter 1. Okay, so you're drawing a horizontal number line to represent mixed numbers between 9 and 11. Just real quick, make sure you recognize the word between. Okay, and you need to decide whether or not that will include 9 and 11. So look back in your, there's a one learning target 1 through 3 worksheet, also your learning target 1 through 3 notes. Should be enough to help you there. Okay, GCF. A lot of us haven't done GCF yet, so I'm going to do an example. I'm going to do 18 and 24. Okay. Here's how you find GCF. This is actually chapter 1, LT number 6 and 7. We're going to be doing this probably Wednesday. So I'm going to give you a little view of how to do it. The first step, so this is what you'll do. This is 2 different questions. You're finding the GCF of this. You're finding the GCF of this. I'm going to do one as an example. First thing you have to do is you have to do your factor trees. So I'm going to break that to 2, and I know that's prime, and 9, which then would break down to 3 and 3. Okay? For 24, I'm going to break it down to 4 and 6, and then 2, and then 2 and 3. Remember, I'm looking for those, I'm breaking it down to the prime numbers that, and I should have drawn a little line, drawn a line through there to separate the 2. It didn't really leave myself enough space. Okay, so all I did was the prime factorizations. Now what I'm going to do, or I did the trees. Now I'm going to take those prime factorizations, so 2 times 2 times 3 times 3, that equals 18, that's from that one. And then I'm going to stack them. So then I'm going to take the prime factorization for 24, 2 times 2 times 2 times 3. Okay? And I got these 2 stacked up. What I'm going to do is I'm going to look for anything that these 2, this line, has in common with this line. So for instance, they both have a 2. I'm going to circle them. They also both have a 3. Do they have anything else the same? No, they don't, because I know that 3 is already gone, because there is no 3's down here. So there's nothing else. Can't circle those 2. They have to be common from row to row. Okay? Now what we're going to do is we're going to take one from each of these common factors. Those are just common factors they share. We know they share a 2. We know they share a 3. And we are going to multiply them. And that is going to give us our greatest common factor, GCF. Okay, so I'm going to recap this one more time, so you make sure you got it. We'll have it down after we do it a couple times. The first thing I did to find GCF is I did the prime factorization, PF. I did the trees. Then I took those prime factorizations and I stacked them up. And I looked for stuff they had in common. They had a set of 2s, they had a set of 3s. I took that 2 they had in common, that 3 they had in common, and I multiplied them together, and that's how I got my GCF 6. Okay? Hopefully you got that. All right, next one, multiples. Now I'm just going to show you multiples of 5. So this is not the answer. I know that multiples of 5 are going to start with the number 5, because 5 times 1. That's the first multiple of 5. 10, which is 5 times 2. 15, 20, 25, and then that could go on and on forever and ever and ever. Right? So it's just counting by 5s, but the one that everybody forgets is everybody forgets to put the 5. The first multiple of every number is itself. So when you think about 8, you had better realize, oh, the first multiple here has to be 8. So I just gave you part of the answer. Okay? And then you have to be able to identify the least common multiple. So that's the multiple that they share. So for instance, if I was doing multiples of 10 now, multiples of 10, I would be looking at this and saying, okay, the first would be 10, then 20, then 30, then 40. If I were asked to identify the least common multiple, I would have to say, well, the smallest one that they share is 10. So the LCM is 10. Okay? All right. Divisibility rules. Do not work the problem out. How do you know whether this is true or false? What's the rule? It's right in your notes. It's right in the Learning Target number 4 and 5 video. Go back and check those. There's a big black sheet that's really hard to read, but you can read it well enough, and it'll tell you how to know if something is divisible by 3 and by 5. Just make sure you not only circle either true or false on both of those, you need to explain on both of them. Okay? Next page. Okay. It's really hard to read on mine. I think it goes to about right there, I think. Okay. All this is, guys, this is just a vertical number line. You heard me reference a vertical number line a bunch of times as being compared to a thermometer. Okay, what makes this a little bit tricky is we haven't honestly covered negatives. We will be covering them. Okay, just think about how a number line would be counting. Starting right here, this is 0. If we went up here, that's 1, 2, 3, 4, 5. Right? So think about how it would count going down too. Okay? There's 2 answers that you're going to eliminate from this, and then there's going to be 2 that are going to get confused. Okay? But I think you guys will figure that out. Russell bought 2.5 pounds of turkey and 3 3/4 roast beef to make sandwiches. Which estimate is reasonable for the amount of meat that he bought? Okay, you should all realize that this would be an adding question because you're just adding the amounts of meat that was bought. Now, since it says reasonable estimate, we can estimate a little bit. Okay, so I'm going to let you go with that and try to figure out if that's really close to 2 pounds or 3 pounds, and if that's really close to 4 pounds or 3 pounds, and then add them together. Okay, this one here, I'll just explain this to you right now. If I wrote something as 2 to the 3rd power, what that means is you would take 2 times 2 times 2. Remember, those dots just mean multiplication. I could put x's, but I think we all need to get in the habit of writing them as dots because that's what's going to look like next year. Okay, so that's what it is. That's how you show exponents. That's an exponent. Allows you to show repeated multiplication. Okay, just like multiplication, 3 times 4 is the same as doing 3 plus 3 plus 3 plus 3. Multiplication showed repeated addition. Exponents show repeated multiplication. So this right here is called exponential form. This right here is called expanded form. The exponent just means how many times you're multiplying that 2 times itself. So if I had 4 to the 5th power, that would mean 4 times 4 times 4 times 4 times 4. There should be 5 there because that exponent says 5 times. So based on that, you have to put it in exponential form. So you have to basically take this and convert it to that. You have to take this and convert it to that. Okay? So I think you'll figure it out based on that information. I feel like you will. Okay? This one, I'm going to let you guys go on this one. I'm just going to kind of circle it. I'm going to see how you guys do. It's a tough question, but I'm going to let you guys roll on that one, and we'll grade that one together. But I just want to see what you guys can figure out, because that's a problem-solving question. The biggest key here, guys, is that word right there. The word profit doesn't just mean how much you sell all the bottles for. You have to, when you profit on something, like let's say I went and spent $10 on suckers, and I sold them all to all of you for $40. I didn't profit $40. I profited, I don't know if profited is a word, but that's what I'm saying. I made $30 because I had to buy the original suckers, so I have to take that out of the 40. So a profit is how much you made after you take out your initial investment. So just think about that one. See how you can do. Definitely I'd have to see work on this one. Okay. You have to know what a sum is. I'm not going to tell you what it is. If you're not sure, you can always look it up on the internet. But just remember, there's a sum, there's a difference, there's a product, and there's a quotient. And you need to know what all those are. Okay? The very back page of this page, there's a whole sheet for work. Okay? I hope this helped. I know it did. Hopefully you guys all get perfects this week. See you guys.